This video will cover section 4.1, antiderivatives and indefinite integration. So antiderivatives, obviously, anti means the opposite of a derivative. So there are two main operations in calculus, and we've already learned the first, which is the derivative, and then the inverse of that, which is called the antiderivative, or the integral. So this whole unit that we're going to look at is discovering the integral and how to find it and also what it represents. So if I'm given that my derivative is 2x, so f prime equals 2x, what is the function? What is f of x? So you have to think backwards here. So if my function is 2x, or my derivative is 2x, think of what function created that when I took the derivative, when I used the power rule. So hopefully this one's pretty easy, and hopefully you thought x squared. And that is correct. The derivative of x squared would be 2x. But with antiderivatives, that is not necessarily the only answer, because you could have also had the function be x squared plus 3. If you took the derivative of x squared plus 3, that derivative is also 2x. So when you take an antiderivative, you have to consider that it could be plus or minus any constant. So to take care of that, the way we write it is f of x is equal to x squared plus c. And we use a c for some constant. So the correct answer for the function whose derivative is 2x is really x squared plus any constant. All right, so for the notation for finding the antiderivative, this is what it would look like here. This symbol right here is called an integral, or an integration symbol. So really, integral and antiderivative are kind of synonymous. So that big elongated S is an integral symbol. So if I take the integral of f prime, whatever I'm taking the integral of is called my integrand. So whatever is inside the integral is called my integrand. Now, this last integral here is referring to the dx part. So just the dx, what it tells us is what you're taking the integral with respect to. So just like if I take dy over dx, that's taking the derivative of y with respect to x, this is how we write the integral with respect to x. And it has a special name. It's called a differential. And we'll talk about that in a little bit in more depth. But it's called a differential. In other words, you need to think of it as you're taking the integral with respect to x. Okay? Then when you find that integral, so if I take the integral of a derivative, then those pretty much kind of cancel out. So the function itself would be called the antiderivative. Okay, and then the plus c is called our constant, but we make it more specific by calling it the constant of integration. So make sure you are familiar with all the parts of an integral, because I will be referring to them by their proper names. All right, so when we find an antiderivative, it's called antidifferentiation, or more commonly, finding the indefinite integration. So careful here, indefinite. There is also another type of integration called the definite integral, which we will learn later. So an indefinite integral is what we're going to start with today. So it says to evaluate or find each indefinite integral. All right, so when we take the integral, we can, of addition or subtraction, we can just integrate each individual term. We cannot do that with multiplication and division, just like when we take a derivative. So if I take the integral of 4x cubed, so this function here can really be split up with the integral of 4x cubed plus the integral of 6x squared minus the integral of 1. And those really should all have a differential alongside them of dx. It's actually considered incorrect if you do not have the differential of dx on the end. All right, so if we take each of these separately, you don't have to write this step, but just for the first one, I wanted to show you how you want to think about this. So when I take the integral of 4x cubed, just like the power rule, we have the power rule for integration. So when we did the power rule for taking the derivative, we would bring down the exponent and then make the exponent minus 1. So when we take the antiderivative, we're going to make the exponent plus 1. So if I have x cubed, then it's going to go up a higher degree order, and that's going to be to the 4th power. Now for the coefficient of x, what we do is we divide by that new power. So 4x cubed had a coefficient of 4, but then when we find the antiderivative, we divide by the new exponent, which in this case is 4. So therefore the 4's will cancel out. Again, you don't have to write that step. You can think of that in your head, but for the sake of this problem, I want to make sure you see everything. All right, so now to the next one. We have an x squared, so that squared will add 1 to become 3. We have a coefficient of 6, which is then divided by 3, so that will become a coefficient of 2. And then finally, we have the integral of 1. So what has a slope of 1? It's just x. Okay? Then make sure we add our constant of integration. So if we were to write this completely, we would get x to the 4th power plus 2x cubed minus x plus c, and that is the antiderivative. Okay, now for part B. This one looks pretty crazy as it's written. So in order to apply the power rule, we need to have everything rewritten before and simplified before we take the integral here. So this is simplified in its radical form, but I want to take all my radical forms and all my negative exponents and put them in exponential form. So I'm going to rewrite this integral as simplified in its exponential form. So this is really x times x to the 1/2, and if you multiply that, that becomes x to the 3/2. Plus, then you would have 1/2 x to the negative 1/2. Okay? So you definitely want to rewrite that before you take the integral. So now when we take the integral, we get x to the 3/2, add 1, and you get 5/2. Then you divide by the new exponent. If the new exponent is a fraction, you simply multiply by the reciprocal. So I'm going to multiply that by 2x. Then I get, I'm going to kind of skip, here's how I do integration. I kind of skip the signs and the coefficients. I go straight to my x. I'm going to leave a space, and I'm going to go straight to my x. Take care of the exponent first. So negative 1/2 plus 1 is a positive 1/2. Then I know that I'm going to multiply by the reciprocal of that, which is 2. So 1/2 times 2 will just be a plus 1. So I saved the sign and the coefficient for last because that kind of comes second in order, and that kind of makes more sense to me. And you can definitely leave your answer like this as long as you put a plus c. Okay? All right, so now for example C. For example C, you cannot take the integral of the numerator and then divide by the integral of the denominator. That's absolutely not something that you can do. So for this one, since I'm dividing by a single variable, then I can divide each term by that variable. So that would be x squared over x to the 4th plus 2x over x to the 4th minus 3 over x to the 4th. And then simplify just like we did with part B. So this would end up being x to the negative 2 plus 2x to the negative 3 minus 3x to the negative 4. Now, this is in the format that I can take the integral. So when you take the integral, the integral symbol goes away. So we have x to the negative 2 plus 1 is negative 1 with a coefficient of negative 1. Then the next term, negative 3 plus 1 is negative 2. So here's why I saved the sign and the coefficient for last, because now I'm multiplying 2 by negative 1/2. Sorry, you're dividing by negative 2. So 2 divided by negative 2 will be negative 1. And then x, negative 4 plus 1 is negative 3. So then negative 3 divided by negative 3 is a positive 1. Let's see. Okay, if that was confusing to you, then write it all out just like I did with part A for B. So then You could simplify this or not. It's totally up to you. If this was multiple choice, they probably will have it simplified back in fractional form. But for the sake of this problem, we're going to leave it alone. Okay, so now for part D. This one has some sign identities in it. So hopefully you remember all your trig. Hopefully you remember your trig derivatives. So hopefully you see that with this one, you need to use your old trig identities from pre-calculus in order to solve this problem. We need to rewrite this in a way that I can take the integral. We hopefully know the integral of cosine. The integral of cosine would be what is cosine the derivative of, which is sine. So the integral of cosine is sine. However, if I cosine over 1 minus cosine squared, I cannot do that. So hopefully we all see the identity 1 minus cosine squared is sine squared. That's something that we can do. Now this still poses a problem. So we still have to rewrite this in the clever form. So as you get practice with these trig ones, hopefully they'll get a little bit easier with practice how to convert these into something you can take the integral of. All right, so what I'm going to do is split this up into 1 over sine times cosine over sine. Okay. Now, still in this format, this does not help me until I completely simplify this. So 1 over sine is the same as cosecant x, and cosine over sine is cotangent of x dx. And probably not very many of you remember this, but hopefully you remember that secant. The derivative of secant is secant tangent. So the derivative of cosecant was negative cosecant cotangent. So if you're taking the integral of cosecant cotangent, then the answer would be negative cosecant of x. No, I forgot my c, sorry. Cosecant of x plus c. Now, if you've forgotten those rules, I will give you a sheet which will have all of those there. If you want to look at it now, it should be in the front of your textbook, all of those trig, derivatives, and integrals. Okay, so that's taking the basic antiderivative. So just a couple of other phrases that you'll see on solving. First of all, you'll see sometimes the word a differential equation, or diffie-q. There's a whole course in college called diffie-q. It's an equation involving x terms, y terms, and derivatives of y. Its solution is y as a function of x. So that means if I'm looking for a solution to a differential equation, we want y equals something in terms of x. So looking at example 3, we have a differential equation. We have dy dx, which is the derivative of y, and we have an x. No y terms, but that's fine. So this asks you to find the general solution. So a solution means I want to solve for y. General solution means when I take the integral and you get the plus c. It means in general, what would the solution be like? So how this works is you have this differential here. And this is a ratio of the change in y over the change in x. So you can actually kind of think of it as like multiplying by the dx. Not really, but that's kind of what it looks like is happening here. I can bring the dx, that ratio, and bring that part up with the 12x squared. So now what you have is you have just the y's on the left side, just the x's on the right side. So if I want to just get y by itself, think about solving equations. If you want to get that y by itself, that d is not a constant, it means a derivative of y. So if I want to get rid of the derivative of y, what's the opposite of taking a derivative? It's taking the integral. So when I take the integral of both sides, the integral of the derivative of y, that's just going to cancel out and become just y. Over here now, we have what looks like an integral. Has an integral, the integrand, 12x squared, and then the differential dx. So that's where that dx kind of comes from. So if I want to integrate 12x squared, that would be x cubed with a coefficient of 12 divided by 3 is 4 plus c. This is my answer. So the only thing really different here that we did is we start out with the dy dx, move the dx over to the integral, and the difference in my solution is that it's an actual equation for y. not just an expression. Okay, so that's what a general solution is. So now, what if I were to ask you a particular solution? So that means for a particular value of C, okay? So the only difference here is that we're going to give you some points that you can plug in for C. And we're going to go ahead and start off with kind of a more complicated one, but I think you can handle it. All right, so if I were to find a particular solution for given f double prime is x squared, f prime at a point is 0, 6, and also f at a point 0 is 5. So when I want particular solution, what that means is I want f of x equals what? And it can't be plus c, it has to be particular. So we're going to start off with the f double prime of x. So if I want to find f prime is equal to the integral of f double prime. So that's equal to the integral of x squared, and then let's put our differential dx. Okay, so f prime then would be equal to x cubed with a coefficient of 1/3 plus c. So now I have this plus c, so I have I have a general solution for f prime right now. I don't want to take the derivative of, an integral of this at this point because I still have c. So now at this point I'm going to use the fact that f prime of 0 equals 6. So f prime of 0 is 6, which when I plug in for x, 0 in for x, solve for c. So I get that c is equal to 6. So my particular solution for f prime now would be 1/3 x cubed plus 6. Now I want to do this one more step because I want to find the particular solution for f. So now I'm going to, in order to find f, that is the integral of f prime, which is the integral of 1/3 x cubed plus 6. So to take the integral, again, we have x to the 4th power. 1/3 divided by 4 is 1/12 plus 6x plus another c. So we go back to find a particular solution and use our point 0, 5 down here. So f at 0 is equal to 5, which is equal to, the x's would all cancel out, so that's equal to my c. So then my final answer would be, yes, you do have to rewrite your final answer, 1/12 x to the 4th plus 6x plus 5. Okay, and that is our basic anti-differentiation for indefinite